Hi, it's Dr. J here. In today's video, I will show you the solution to question 14 of the 2021 WACE paper. This question combines ideas from electromagnetism and also gravity and motion, where we're looking at tension and circular motion. Here's the diagram. So we have two parallel plates here, one charged at positive, one charged at negative. And between the two plates, we appear to have some kind of ball there. So a 0.200 kilogram metal sphere with a net negative charge of 2.72 millicoulombs is suspended by a 0.8 meter long, almost massless string in a uniform electric field. The plates of the field are 1.2 meters apart, and the potential difference between the positive top and the negative bottom is 1.8 by 10 to the 2 volts. Firstly, calculate the strength of the electric field. Okay, let's write some detail from the information that we've been given. So this is 0.8 meters long string. Between the plates we have 1.2 meters. The Q that we've been given is 2.72 millicoulombs, so that's 10 to the minus 3 coulombs. And the mass that we've been given is 0.200 kilograms. Okay, so we're starting off looking for the strength of the electric field. If we look at our formula in constant sheet, we have that electric field is equal to voltage over distance. So if we have a look at our diagram with all our information on it, the voltage that we've been given, sorry, I've forgotten to write that in there, is 1.80 by 10 to the 2 volts. So that's 180 volts divided by the distance between the two plates, which is 1.2 meters. And we then have 1.50 by 10 to the 2 volts per meter. So they've already given those units just there. Okay, we now then move into a gravity and motion type question. It's asked you for the tension in the string. Okay, so from this, what you've got to realize is that there are two opposing forces here. So you've got the tension in the string due to the mass of the ball, and then you're going to have an attraction between this negative charge on here and this positive plate. Okay, so we've got two things we need to take account of. We need to take account of the electric force, and we also need to take account of the weight force, and they're two opposing forces. So let's start with the easy one, which is the weight force. So that'll be mg. So I have a 0.2 kilogram mass and a gravity of 9.8, and that gives me 1.96 newtons, and that's going to be a downward force. Now the electric force, we would need to have a look at our formula in constant sheet, and what we know is that electric field can also be written as force over Q. So we've just worked out the electric field, so let's use that. So I've got 150 is equal to Fe, which is what we're looking for, divided by Q, which we have as 2.72 by 10 to the minus 3, and that gives me 0.408 newtons, and that's going to be upwards. So overall, the tension is going to be the sum of forces. So the tension will be equal to 1.96 newtons down, take away 0.408 newtons because it's up, and that will give me a total of 1.55 newtons. Okay, tension doesn't have a direction, but overall that force is going to be downwards. Okay, let's have a look at the next part. So the sphere is pulled to one side and released. At the bottom of the swing, the sphere is traveling at 2.8 meters per second. So we've got a velocity here of 2.8 meters per second. The other thing that we know is that if it's doing a swinging motion like that, we're starting to think about, oh, there might be some circular motion here. So that's an interesting sort of combination of ideas in this question. So it says, draw a free body diagram of the forces acting on the sphere in this position. Label all the forces. Do not show the net force acting on the sphere. So we know that it has a force of, mg. So that's its weight force. We also have an electric force acting on it. That's the electric force that we worked out before, 1.55. And then what we know, from circular motion, something has to provide the centripetal force, and that centripetal force will go towards the center of the circle. So overall, we need to have the tension is going to provide that. So our tension is going to change from the previous question. All right, so the tension and the electric force has to counteract the weight force in order to produce the centripetal force, which is produced by that velocity. So let's see what it's going to ask us now. Okay, so derive an expression for the net force acting on the sphere in terms of the forces that we have there. So the net force, which is our centripetal force, is going to be equal to the tension plus the electric force, take away the weight force. Okay, so I've already taken account of all of my directions here with the pluses and the minuses. So when I pop in the value for G, it's going to be positive 9.8, okay, because I've taken account of its direction, the fact that it's downwards. It then says calculate the tension in the string at the bottom of the swing. So we know that we've got that the overall force has to be the centripetal force, which will be mv squared on r, and that is equal to the tension plus the electric force, take away mg. So the mass of the ball was 0.2. The velocity is 2.8 squared. The length of the string we drew on our diagram was 0.8. So that's mv squared on r. We're looking for the tension. The electric force we found from before was 0.408. And we know that the weight force is 1.96. Okay, so therefore, if we pop all of those numbers in, okay, so the 0.2 times 2.8 squared divided by 0.8 gives me 1.96. Take away 0.408 plus 1.96, and that gives me a total of 3.51 newtons. So there we have the end of the question. So we've now solved question 14 using ideas from both electromagnetism and gravity and motion. It is often helpful to write your info down as we're going along to assist you in pinpointing the correct concepts needed to solve. Remember that every question they ask you is something that you've seen before, that you know about. It's just a matter of deciding what concept they're targeting. Thanks for listening to this video. If you would like me to work through any particular problems, just let me know in the comments section. Thank you.